Okay, so this video is going to discuss Fischer projections and different stereoisomers. And so what you're going to learn in this video is the proper depiction of a Fischer projection, how to determine the configuration of a Fischer projection, and we're going to look at some diastereomers that are also Fischer projections, and we're going to look at the Fischer projection of glucose and figure out how to determine the configuration, the R or S configuration for that. All right, so basically a Fischer projection, you can see here, we know that carbon is a tetrahedral and or tetrahedron, and so the Fischer projection is basically looking at the carbon from the top, right? It's like if you were holding this molecule in your hand, it would be like looking at carbon from the top. All right. So in a Fischer projection, it's important to understand that the horizontal lines here and here are wedged, and then the vertical lines are dashed. That means that the vertical lines are going back into the page, and the horizontal lines are coming out of the page. And so in order to assign configuration to a Fischer projection, is very simple. All right. If the hydrogen is vertical, right, meaning up or down, it doesn't matter. If it's vertical, you go through your normal procedure for assigning configuration. First, you assign priority, and then you determine whether or not the groups are oriented clockwise or counterclockwise. And you should remember that assigning priority is based on atomic mass. All right. So here's the priority: bromine is 1, this carbon is 2, and this CH3 here is 3. Why are these two carbons different? Well, they're the same atom, they have the same atomic mass, so we have to go to the next atom. In this case, it will be oxygen. In this case, it will be hydrogen, so this is priority 2. So when we look at this, all right, and we count here 1, 2, 3, we see that that is actually counterclockwise, right? So the configuration here is S. So if the hydrogen is vertical, you simply assign priority, and if the groups are oriented in a clockwise fashion, then it's R. If it's counterclockwise, then it's S. All right, so let's look at another example. Here, the hydrogen is no longer vertical, it's horizontal. Remember, if it's horizontal, that means it's on a wedge. All right, just like these two are on a dash or a dash line. Sure, yeah. Okay, so if it's horizontal, there's a little trick that you have to remember. All right, you assign priority, right? And let's look now. The priority here is 1, 2, 3. That is actually clockwise, right? That's clockwise. However, if the hydrogen is on a wedge, meaning if the hydrogen is on a horizontal line like this, that means it's on a wedge. And so if the configuration with hydrogen being on a horizontal line, if the configuration is clockwise, you simply reverse it. So normally this would be R because these things are oriented clockwise. So if that's the case, if hydrogen is on a horizontal line, then the configuration is the opposite of what you see. So this is 1, 2, 3. Normally that will be R, but because hydrogen is on the horizontal line, then the configuration is actually S. All right. You only do this for Fischer projections. All right. This does not apply to um, other depictions of chiral centers, but only for a Fischer projection, and only if hydrogen is on a horizontal line. All right. So here's some other Fischer projections, and I want to actually look at these in 3D. So here's a depiction of isomer A. I'm just cutting it around a little bit so you can, let me straighten it a little. That's iodine, carbon, and hydrogen. And on the bottom carbon, you can see carbon and then hydrogen. Let's get a better view of it here. Let's turn it a little bit more. Okay, so that's A. So in order to determine the configuration, the stereo centers at A, we have to turn it so that the hydrogens are facing back. All right, and we have to think about each stereocenter separately. So this is group 1 here, this is group 2, and this is group 3. 1, 2, 3. This is isomer B. Notice the hydrogens are on opposite sides. Iodine is pointed back. Here's nitrogen. Let's turn it around and get a better look at it. So you can see the two horizontal substituents here and here are on a wedge line coming out of the screen, and then the vertical substituents are going back into the screen. So, with these Fischer projections, you treat them just like you would treat a 2D Fischer projection of what they're drawn in 3D here. And the way you treat them is if hydrogen is horizontal, then you prioritize, right? And then if you look at the way that the groups are oriented, iodine is 1, this carbon down here is 2, and then the methyl group over to the right on the top carbon is 3. So when you count, right, it looks like you will be counting in a counterclockwise fashion here, 1, 2, and 3. And so if that's the case, remember the rule. If hydrogen is horizontal, then what you see, you reverse it, right? And so even though that's counterclockwise, that would be S, but the fact that hydrogen is horizontal makes it R. All right, let's look at the bottom stereo center here, right? And again, you're applying the same principle to this as you would to a 2D Fischer projection, right? So your hydrogen is horizontal again here. The groups are prioritized like such, right? Nitrogen is 1. The carbon on the top stereo center is 2. And then the methyl group is 3. So if we count that, again, that is also counterclockwise, right? Under normal conditions, if hydrogen was vertical, that the configuration would be S. But because hydrogen is horizontal, the configuration here is also R. So the overall configuration for this molecule is RR. Okay, so now let's look at glucose. Glucose is just one big Fischer projection. When you see it drawn this way, you'll see it on standardized tests this way a lot. And so let's look at the carbon here at this chiral center, and let's determine the configuration at this chiral center. One thing you need to remember, again, this is a Fischer projection, so these two groups are on wedges, and then these two groups are on dashes. All right, so here's the question. Do you remember what I said earlier? When hydrogen is horizontal, or the lowest priority group is horizontal, then the configuration, at whatever configuration you see, then the actual configuration is the opposite of that. So let's look at it. So here are my groups. This is group 1, OH. Group 2 is the aldehyde here. Group 3 is this carbon that's attached to all of these carbons down here. So really group 3 is this whole group. All right. And so the reason this group 2 is higher priority than this one. This is C with 2 bonds to oxygen. This is C with 1 bond to oxygen. All right. And so when we look at this, this is 1, this is 2, this is 3. That is counterclockwise. So it should be S, but because hydrogen here is on the horizontal line, it's actually R. So if you have any questions, you can email me at arussell@tuskegee.edu, or you can come by my office, Armstrong, room 102. Thanks.